Thank you for joining today. Today's demo topic will be metal casting in computer vision. It will be led by our solutions engineer, David Park, and this is a live demo, and then we will do a live Q&A. If you have any questions, feel free to drop those questions in chat, and I will be reading them. And then at the end of the presentation, we'll take live questions. All questions around computer vision, metal casting are encouraged. We also encourage you to join our community as well as sign up for LandingLens. We will do a follow-up with the recording and email and social media connections tomorrow, because we would love to learn a little bit more about your use case. In addition, if you have any ideas that you would like to see for our live Wednesday demo, let us know. We encourage our community to share their ideas. With that, I'll turn this over to Mr. David Park. Take it away, David.
Thank you, Adrian. Let me start sharing my screen. So hello, everyone. As Adrian mentioned, my name is David Park. I am a solutions engineer here at Landing AI, and we are very excited to showcase our technology today. Just to set the context for the demo, Landing AI provides a data-centric, end-to-end computer vision platform that really empowers our users to tackle any computer vision use cases and build state-of-the-art models using our easy-to-use platform and user interface. And for today's demo, as Adrian mentioned, we have a data set containing metal casted parts. There are submersible pump impellers, steel discs with vanes and centrifugal pump. And to provide a little bit more context around the use case, we'll be using our platform to classify and detect metal casted parts with defects. And we will do a quick overview of what type of models and project types we support in just a bit. In terms of the agenda, we'll do a 15-20 minute demo, and we'll do a live Q&A session at the end. We'll leave 10-15 minutes for question and answers. Okay. Let me jump into the platform. So this is the landing page of Landing AI. And as you can see at the bottom, you have your most recent projects. We organize each experiment as a project. So anytime you start a use case or tackle a use case, you'll do that by creating a project. If I click on the View All button here, bottom right corner, you have access to all of the projects within your organization. And to start an experiment, you simply click on the plus sign here on the left side, and it will create a guided user experience with all of your model type and project type options at the top. And speaking of, we support 4 different model types. First is object detection. So if things like location, general size, or if you have multiple defects on a part, object detection is a great model type. Segmentation is very similar, but it provides a lot more pixel level granularity and sensitivity. But keep in mind that the data labeling process can be laborious. However, we just released our SAM-based labeling tool. So if you're familiar with segment anything from release from Meta, we leverage that technology to help expedite that labeling process. Third is classification. So if you want to classify an entire image, is this part defective versus not? Classification is a great project type. Last but not least is visual prompting, which is our latest innovation here at Landing AI. It's a prompt-based modeling technique. You can kind of think of it as a ChatGPT, but for computer vision, where you can prompt and train model with as little as 1 image by providing a few sample pixels instead of a perfect segmentation mask. Okay, so we'll walk through the classification model type first. And as you can see at the top, we'll provide a guided user experience. For classification, just industry best practice, ideally you have all of the defective part in one folder and all of the good parts in a separate folder. And if that's the case, I can actually upload the entire folder structure by clicking on the more options and then classified image. and I can drag and drop those two folders. And as you can see, I have one folder called good-no defect and second folder called no good-defects. So if I upload these 99 images, the main benefit of doing that is we will not only upload those images, but we will also create a label for all the images in this folder using the folder name. So all the parts that were in the no good folder will be labeled as not good and vice versa. But for whatever reason, if the image is incorrectly labeled, you can always go into each image and change the label, or even create a new class if you have multiple classes that you want to classify. Once I am done uploading and labeling the image, now I'm ready to train a model. You can see the blue train button on the top right corner. And once I click on that button, you can see exactly what we're doing step by step on the right side. We are provisioning the necessary GPU resources to train a deep learning model. And once we've done that, we will actually go through the training and the learning process. As you can see, the learning curve on the right side there. And once the model is done training, we will calculate the model performance based on the ground truth or the label that you provide for each image, and spit out the model performance all within the platform on the right side. Okay. So this will take a few minutes. So instead of waiting for the result, I will switch over to a separate project. And as you can see, we trained a model using over 7,200 images, and we were able to achieve 99.5% precision and recall. And below the performance metrics, you have access to the confusion matrix. So all the correct predictions will be listed here and the incorrect predictions below. And from here, we want this to be an iterative process. So if you click on the missed predictions and go into those images, you can perform, visual error analysis to try to understand why the model missed certain predictions. Maybe it's lack of, class representation in your training data set, or it's just a wrong prediction, in which case you can start to understand your model behavior. And speaking of model behavior, for all classification projects, we offer a defect heat map feature. So if I click into that, now go to the not good parts and click into an image, you can see the heat map. So corresponding pixels that are most activating for the model. So this is kind of a model reasoning on why it made certain predictions that it did. So here, it can also help you understand model behavior and potentially how to improve your model performance as well. Okay. Just want to do a quick check of the chat. I think we're okay. Second model type that I wanted to review is object detection. So as I mentioned earlier, if things like location, general size, or if you have multiple defects you need to be able to specify using the model, you can use object detection. As you can see, I labeled 9 images already. So if I jump into the 10th one, which is the minimum requirement to train a model using LandingAI, I can select a class again, or create a new class and use what's known as the bounding box, these bounding boxes to label my defects for my images. Once I've labeled the first 10 images, we will give you a pop-up saying, hey, congratulations, now you're ready to train a model. Of course, you can continue to label more images, but if you want to kind of train train a MVP model, which is 10 images, you can do that by labeling 10 images and then training a model. Same process as classification, and that is by design. No matter what model or project type that you're using on the platform, you will have a similar user experience. Once you click on the train button, we're provisioning the GPU, training the model, and calculating the model performance all within the platform. Similarly, this will take a few minutes, so I will jump to a preloaded result with 7,200 images plus. And as you can see, we were able to achieve 96.9% precision and 86.1% recall with the labels that we provided the model. So here, if I wanted to perform, again, visual aware analysis, I can click into the 3 misclassification. I go to the image view. I'll just stay here. If I click into the image, it looks like the model mispredicted or didn't predict this as a whole. Maybe it's not as big. Maybe it's the shadow that's kind of introduced into the image. Whatever the case may be, you can add more or label more images that are similar, retrain and iterate through that process. And for some cases, it may be that you didn't provide a ground truth. And if that's the case, you can always provide the ground truth and retrain the model to improve the model performance. Okay. And for object detection, we have a feature called check label quality. So if I click into that button here, we will trigger a label quality checking job. So what this does is we compare the prediction versus the ground truth that you provide. And if an image is mixing a prediction and the model is highly confident, it will actually suggest that as a label or ground truth, again, helping you expedite the labeling process. Okay. And you also have access to the confidence threshold here. Last but not least, we will demo our SDK very quickly. Actually, before we do that, we'll go over the deployment options. So once you're confident with the model performance and you're ready to deploy the model into production, there are a few different ways you can do that. First is by clicking on the predict button. If you wanted to test out, 1 or 2 images using the platform, you can simply drag and drop some images here. But if you wanted to deploy the model, you can click on the deploy button next to the predict button. And you have 2 options in terms of deployment. First is cloud deployment. So if you want to access the model programmatically, maybe you have an application and you want it to be AI driven, you can deploy the model as a cloud endpoint, and you can access and make predictions, again, using our SDK, which we'll go over in just a few minutes. Second option is the edge deployment option. LandingAI also provides a edge computing software. So if you wanted to download the model into your production line in cases of manufacturing or pharmaceutical use cases, you can download the model into your edge environment. For today's demo, we will review the cloud deployment option. So once I select the option and create a new endpoint and deploy, it will ask you to name your endpoint. We'll call it webinar demo 2 and create. And once I do that, it will create an endpoint under the cloud deployment options. And from there, you can deploy the model itself once it's created. Okay. Just a few things wanted to go over in the deployment page. If you wanted to access the model via the SDK, you can copy the endpoint using this button here. We also have a QR code or mobile inference. So if you wanted to run an inference via your phone, you can generate a QR code for your end users or your customers. And last but not least, below that, we will provide you the API endpoint, and you can generate your API key under your API key section on the top right corner. Okay. So if I wanted to generate inferences using, let's say, this endpoint here, I can again copy the API endpoint. And I can go into any kind of IDE of your choice and generate or access the model programmatically. You can pip install or conda install LandingAI depending on your environment. I can import the necessary libraries. In this case, it looks like I'm missing an L here. And then I can input my API key. We'll just copy and paste this for security reasons. And my secret. And again, I copied over the API endpoint here and have the ID. And I will load the image as an API NumPy array. And I can actually run the prediction by calling our predictor object from Landing AI. Once the inference has been run, has run, I can see the prediction. You can see that object detection prediction. You can see the confidence score, the label name, and the coordinates for the bounding box. We also have a toolkit to help visualize the prediction using the overlay prediction. And once that is done, I can use that image to save that image to a different folder or directory. And I can also visualize the prediction made by the model overlaid on the image. You can see the defect name or object name, and then the confidence score, corresponding confidence score on the right side. Okay. And we also have a SDK doc on our support center. So if you go to our support center, type in SDK, you will have access to our open source GitHub page for both Python and JavaScript. So depending on your language of choice, you can leverage our SDK using our GitHub page. Okay. So that's everything we prepared for today in terms of the demo. So we will open up the floor for any questions. It looks like we have some in the chat, perhaps. So I will go ahead and open that.
The first one we have, David, is what is the minimum amount of images required to achieve 80% or higher accuracy?
Yeah, that's a great question, Charles. I think it really depends on the sensitivity or complexity of your use case. Often than not, if you can get consistent images and the defects are visible, I think our rule of thumb is 10 by 10 pixels. So if you can acquire images so that you capture the defect or object of interest 10 by 10 pixels or higher, we tend to perform really well. But again, it depends on the complexity of the problem, the number of defects or classes or objects that you're trying to identify. But we're happy to put that to the test if you're interested. We offer a free trial on our website. I'm sure Adrian mentioned this before. So if you want to go on our website, and if you have images that you want to test, you can do that on our website.
Next
and I think
question.
the second, yep, go ahead.
Oh, actually, I'll let you want to take it. It was about Jupyter, sharing the Jupyter notebook.
Yeah, we can definitely share that notebook after the call with the recording.
The next question, can you do multiple images versus one at a time?
I'm not quite sure what the question, are you asking if there are multiple, are you asking if you can inference multiple images? Charles, if you can clarify that question. Can I train on 10 images and load the same model, use the model for assisted labeling? Multiple images versus one at a time or video. I think I know what you're asking. The short answer is yes. We can absolutely analyze video files. So what we do is we actually chop it into different frames, number of frames per minute, and then we analyze them by inferencing per frame of your choice. And you don't have to infer one image at a time using the API. We can increase or decrease the rate limit depending on your use case, and we can support high throughput use cases.
Charles, I admitted you, so if you want to go ahead and ask that question again for clarification.
Oh, thanks. Yes. Basically, let's say I have, 100 to 200 photos and I want to analyze all 200 photos. And I want to spit those results out with the bounding boxes, etc., into a folder for a report, basically, right? Versus one
Yeah.
at a time. Versus one at a time. Yeah.
I see. Yeah, there are a few different ways to do that. I think the easiest way is to just simply upload more images into the platform. Once you train a model and any subsequent images that you upload, we will infer on them automatically. And we actually are about to release our report capability where any new images that you import, we actually provide an Excel report. So I think you're kind of asking around like batch processing, right?
Yeah,
Yeah,
exactly.
yeah. So we can support that as well, depending on
Now,
batch
is that
size.
only offered on the enterprise level or is that on the starter level?
I believe it's only offered on the enterprise, but I'm not sure. Adrian and I can follow up with you after the call if that's okay.
Sure, that would be great. And
Yeah.
the last question. Let's say I train build a model, 10 images. I got good 10 by 10 pixel on 10 images that say represent 1,000 images. And I take those 10, I label them correctly, build a nice accurate model. How can I load that same model back into Landing and use that model as assistant labeling so I don't have to label the rest of the
Yeah,
remaining?
great question. Yeah, excellent question. So for classification, any inferences that you run or object detection, any inferences that you run and that you deployed will be listed here. So you can actually, it looks like someone messed with my endpoint here, but this is a new image the model has never seen, and that I ran an inference using an API endpoint, and you can see the predictions made by the model. It says there are 2 holes, and these are the confidence threshold. I can actually mark it correct and then feed it back to my data page, and then use that as labels and retrain the model. So we have a full feedback loop to kind of support that workflow. Did that answer your question, Charles?
Kinda. I was trying to mess with that. You could say correct, but then if it's not correct, how do you correct it? And then,
Yeah. So I can actually select the ones that I want, and I can add the images to the build. And once I do that, it will show up on the build page. And the newest images will be, I believe, at the top. You can go into that image and make any kind of adjustments that you need to retrain the model.
Okay, I see now. And then I know I said that was the last question, but this is definitely the last question. Instead of using the QR code for the mobile inferencing or whatever, which is pretty cool. And again, same question on that, uploading batch quantities from the mobile inferencing option. Let's say I have 200 images on my tablet and I want to analyze all those images right then and there.
Yeah.
And then, what if I create the endpoint, how can I share? Because I know you went into a Jupyter notebook and you started getting into the SDK, but do I have to create an app, or how can I share the endpoint, or is it a link that I'm trying to demo this for a client, I want to show them.
Yeah.
Yeah. Is there a link I can send it to them, and then they can click on the link and test it?
Yeah. So we don't and I guess the QR code is not enough to kind of demo that to the customer.
I think it's great. I think it's a great demonstration of the model, demoing the model.
Yeah.
But as far as I want to demo batch 10 or 20 or 30 pictures at a time. I want to show them a batch processing display of results, basically.
And you want that via a mobile app? Is that the
Yeah,
criteria?
if it can be, yeah, that'd be so cool. And then but my goal is to use the SDK to build, I guess, an app, a custom, user interface where they can. I'm trying to make an application basically out of my models. Take these models and make a reporting application.
Yeah. So if you visit our SDK GitHub page, we actually have some example applications that we built, and this is a growing list, so we'll build more on this. But we used a tool called Streamlit to kind of quickly create these AI apps. So if you have any creative ideas, we can potentially collaborate on creating a next one, maybe a mobile app or something like that.
Cool.
Yeah.
So offline, maybe I can email you directly. We can go over my use case more in detail.
Yeah, absolutely.
Okay, thanks, David.
Of course.
Thank you, Charles, for that question. If you could put yourself on mute so kindly, we'd appreciate it. Next question, David, is do you have an SDK for any mobile platforms currently? Or if you've already answered that.
Yeah, I think it's a very similar question to Charles. We do have a few sample applications, but again, if you want to brainstorm different app ideas, please reach out to myself and Adrian, and we're happy to jump on a call to discuss your use case.
Next question: how can we apply different algorithms of training?
Great question. So I guess this is a question around like bringing your own algorithm to the platform. Is that correct?
Let me see if Varsha is online, and what I will do is unmute them. And I'm gonna Varsha, I've unmuted you. If you'd like to ask that question live, feel free to.
Okay. Thank you. Yes, my question is like, if there are multiple models available in machine learning and AI, so how can we apply different models of training?
How can you apply multiple models on your use case? Is that the question?
No, like there are different, like I have working on UNet model, VNet model. There are multiple convolutional network models are there. So can we apply, or like the one thing I have seen in your presentation is that you have used some API page. You have opened some API page. I think from there you can import libraries of Python, and I think it is possible to import that models from there. Am I correct?
Yeah. So let me kind of take that question into two different parts. I think the post-processing script is exclusive to our edge computing software, LandingEdge, where you can import different Python libraries to do any kind of post-processing. And second part of the question, or second part of that question, I guess, or my answer is if you want to chain different models using the API, we've done that with multiple customers where first you train an object detection model to identify a defect. And then we either do a classification or something a little bit more precise, like a segmentation or even visual prompting to isolate that defect to calculate maybe area or find a little bit more granular information via model training. So you have object detection. It returns a coordinates of the bounding box. We use that coordinate to crop that image, and then we run a second model on that cropped image alone. Did that answer your question, Marsha?
Okay. I'm looking at this model, and there is one thing on the screen. I can see that the model underscore V1. What it is? Can you please scroll down this? Is there any other option?
In terms of different models you can use?
Yeah. I want to see that there are options available for different models.
Yeah, so currently our platform doesn't support external model. We have our own proprietary models that we've hyper configured for the data-centric approach. So I mentioned that you can train a model with using little as 10 images, and that's because we've configured our models to be highly performant in kind of a reduced search space.
Okay, thank you.
Yeah, and if you want to do some sort of benchmark testing with an open source model, we're more than happy to have a conversation with you as well.
Okay, I'll see that.
Great, thank you. And if you could be so kind as to mute yourself, that'd be great. Another question, David. What does the process look like for? Oh, I'm sorry, we already had that question. Let's see. Next question. Which deep learning model is used to train the weights?
Great question. Unfortunately, we can't divulge too much into our actual model architectures because of IT or IP concerns. We use state-of-the-art, transformer-based and CNN models combination that we've kind of architected ourselves for our model and our backbones.
Excellent. And let's see. Let's see here. For any label, automatic process or application, for label, is there an automatic process or application there? Not quite. You know what? Let me get Abhishek. I'm gonna unmute you if you'd like to ask that question. I'm not quite getting what you wrote down here. Go ahead. You're live now.
Yes, sir. Am I audible?
Yes,
you are.
So in this data set, we have some images. I think 1 lakh images are there, and label is not defined in those images. So it is a very tedious task to label all the images and get the final classification of the model. So how we can label this type of data set, sir? Is there any automatic process for labeling?
Yeah, so I think I briefly showed it during the demo, but we have a check label quality feature where for object detection, if you click that button, we will run a quality check job to say, hey, the model thinks this is a crack or a hole. Is this correct? And you can either accept or reject the recommendation to kind of help automate your labeling process. So it's a model assisted labeling for object detection. And we didn't get a chance to demo this today, but we just released our SAM-based labeling. So if I'll just do a sample data for segmentation. If I wanted to, let's say, label the fire, I can create a class, and we have a smart labeling feature for segmentation where I can use the tooltip to kind of prompt and say, hey, this is a fire, this is also a fire. And as I prompt more and more, the labeling gets smarter. And as you can see, we've created a pretty much a perfect mask of the fire. And if I save the label, we are creating that label for the fire. I can create another class for the sky or tree, whatever the case may be. So this is a SAM-based labeling where we can help expedite your labeling process.
We have to perform only one segmentation, then automatic all the images will be segmented like this, sir?
No, this is image by image. So you would have to go into the next image.
If we have 1 lakh images, so we have to perform this manually?
Can you repeat that second part of the question?
If we have 1 lakh images of such type, so we have to perform the segmentation like this, labeling like this for all 1 lakh images.
For the initial training, yes, we need 10 labeled images to train a model. And once that is done, you can actually run an inference on that and use the mask to use that as a label. And you can import that onto the platform with the image.
Okay.
Yeah, that's what I was asking earlier, David. How do you import that and use it as a labeling?
Yeah, we accept Pascal VOC format. And I think for segmentation, you need to convert the inference result as a PNG mask. We can send you a script or work with you on your use case to help with that process.
Thank you for those great questions. If you could put you guys on mute, we have time for maybe one or two more questions, David.
Sure.
Okay. Next question. How do these solutions perform for real-time detection? Example, model is deployed on a mobile wearable device like smart glasses.
I think the question is related to the performance. It really depends on your network and your edge capabilities. So if you need like high throughput use cases, Landing Edge can support up to, I believe, 30 inferences per second. So if you have a high throughput use case, for example, in manufacturing, where you need to infer every part very, very rapidly, we can support that on the edge computing side. And if you need to run the model programmatically, it's a function of your network, your architecture for the app. There are various things that can influence the performance of the model.
And keep in mind, everybody, that if we didn't get to your question today, we will be doing live follow-ups tomorrow morning with a recording. We'll make sure we reach out to everyone and get those questions answered. We're going to take one more live question. This is from Angela. I'm going to unmute you in a second. And go ahead, Angela, and ask your question.
Hi, everybody. Thank you. This is a beautiful tool. I've been able to test it a bit. So I'm just curious if use cases are protected by NDA between the user and the Landing AI team. I'm more on the research side, so I tend to want to protect our data and potentially consider you guys as collaborators. Does that make sense?
Yeah, great question. Absolutely. We do not have access to your project until you give us explicit consent. And we also provide a regulated tech stack. So for highly regulated industries like pharmaceutical, life sciences, verticals, we can actually help with the validation process, and we can bring in one of our house expert for the validation process if you're in that area as well. We're protected by the NDA. We'll never share your data, your model weights. There's no cross contamination across the organizations.
Okay, perfect.
Does that answer your question? Yep.
Absolutely. Yep.
Thank you, everybody. We are over time. We do like to keep this within 30 minutes. So I appreciate everyone's awesome questions. And again, if we did not get to it, we will be doing follow-ups immediately. Let me pop in my email address in chat right now. And if you'd like me to reach out to you today, just drop me an email and we'll get something scheduled. But do expect a follow-up by tomorrow morning from David and myself with the recording, and we'll put your question in there and we will do our best to get that question at least answered fundamentally. I'll have my calendar link in there so we can schedule some time. Again, please join our community. David, could you pop up that one slide with all the CTAs there, which are our call to actions?
Yeah, sure. Give me 1 second.
So again, please join our community. Also, sign up for LandingLens, which is a free 30-day trial. We have a number of medium communication platforms that you can connect with us. We have chat on our website. We'll be bringing chat into LandingLens in the next couple of quarters. But if you have a question, you're welcome to hit us on the website. Again, we'll be doing follow-ups. We're very active in the community. So we encourage lots of questions, and we look forward to connecting with you and learning more about your use case. Thank you for your time today. Have a great Wednesday, and sign up for our future our webinars. Thank you. Bye.
Thank you.